Já.
Foi?
Vai.
We saw very fast final use of automotive and distribution energy, and some application, special applications that I saw. And we start with stationary power, and some application with stationary fuel cell that I saw. Generate electricity, and we start with stationary power, not provide clean energy fuel cell, reliable of generate electricity to improve off-grid power, not provide clean electricity, reliable off-grid power, also on-grid. And this off-grid power, they work in business, a lot of communication of telecom system on-grid, utilities, lift, they work in business, different kind of a lot of communication of telecom system, fuel cell system, utilities, Hadoop, Apple, Lift, NTT, and CBS, different kind of fuel cell are using Delmar, fuel cell system, Hadoop, Apple, NTT, CBS, Walmart, Coca-Cola, Cox, Delmar, Drumstick, eBay, Google, Honda, Lift, big companies, Walmart. For the fuel cell, we can have different kind of size, different kind of from kilowatt, 2 megawatt, to 40 megawatt. The stationary fuel cell, we can have different kind of size. You can see different kilowatt, 2 megawatt, to 40 megawatt fuel cell engine. Here we can see different size. Fuel cell is a fuel cell for those a fuel cell engine also working hydroelectric cell. Molten carbonate fuel cell. Here is a
very nice company.
Fuel cell for
they work with solid oxide fuel cell, very high-tech technology. It's like the Canadian Ballard. They work with PEM fuel cell. They have bigger size, but the maximum is 1 megawatt. It's a rely on. They use for work. The company work for telecom system. They have one, the cell, the size normally 5 kilowatt for backup system. Hydrogenics, another Canadian company, they work with high temperature electrolyzer, PEM electrolyzer, also stack, 30 kilowatt stack model. Intelligent Energy, another company that work with also is a very famous company. And also LG, SOFC, Korean company, Toshiba company, another different kind of LG cell. The same. Here from Toshiba, we saw here they have this the power generation is about 1 kilowatt, 150 to 70 watt. The efficient is 39%. And now, 39%. High heating value, low heating value. Total efficient, 95%. Cell design for 80,000 hours. It's fantastic. The OE put 50,000 hours for cell, is 80,000. Output voltage, 100 volt. Temperature, minus 10 degrees, Celsius degrees. It's nice. Look here, hot water temperature. Then this cell here, they produce hot water. Japan, he prefer to have lower efficient to have more hot water. The hydrogen to heat the water. The fuel, LPG or natural gas, both they can use. noise, no noise, absolute no noise, automatic, startup time, 60 minutes. Then it's too much. You need to have a backup system here to wait, to backup, to start up. Small, light, this is the product. And here is where you stored the water, 200 liter water. Please.
Professor, I do not understand the difference between electrical efficiency and total efficiency.
Me too. But I think he understands is the stack system, and I think here is the efficient of the electrical system. I think is that, but it's no. There is no sense of the total is higher than the stack system. Please.
Just a suggestion. As it produces hot water, it may be like a cogeneration or CHP. Then they usually add up both the part of thermal energy, the hot water part, plus electrical energy is just a gas. They usually do that when they work on cogeneration system.
Okay.
Maybe.
Okay. This is new for me too. I take this yesterday to show you some new application. I saw this here. I think was okay. Good question. Thank you. Another is the Duzen. Here's another. There's also a Korean company. They have different kind of size. Output 40-60 kilowatt. It's a big stack. The electric put is 46. And the efficient here, you know. Here, look here. Peak overall efficient. And here, electrical efficient, 43. Maybe your answer could be easy to understand here. Gas consumption, what they used. The heat. And here what they use, natural gas, that they need a reformer. Emission, very low emission. There's some code standards. And here is the address. Another application is ammonia. For 10 years ago, I saw a stack on Hanover Fair for ammonia. Ammonia is a molecule that has a lot of hydrogen inside. This is fantastic. A molecule that you have more hydrogen. And then, but the ammonia is a portion for a fuel cell. Then you need to do a reformer and put on inside the cell. But they say that the cost is competitive with the diesel generation. It's fantastic. And I saw here 50 cents per 1 kilowatt hour. Very low. Here's from Fuel Cell Energy. It's a big company, and they produce hydrogen from an anaerobic digester. He produce the biogas, on-site hydrogen fueling station, water treatment, and here is the direct fuel cell power plant to fueling the car. For portable application. There is not new zinc, but they use some equipment for mobile and for computer. The problem is to store the tank. This is a reason that they like to use methanol in capsule in some little tank. And there is some application also. Here's the some application. Here's the mobile and stored energy. You can, with methanol, you can have a laptop running for 1 week. Transportation is changed a lot, very dynamic, and you have a lot of different cars, plug-in cars, different concept of hybrid car with big size stack, small stack, big size lithium battery or small. Would have basically two companies. They are working today very hard. It's Hyundai and Toyota, but also Daimler Chrysler had worked a lot on the history with hydrogen, but not only, but also GM and Fiat and Peugeot, Renault, and Tesla. Tesla are working also with fuel cell, because we can have more autonomy with the fuel cell as on each new kind of technology of lithium-ion battery. I show you some drone today. A lot of drone today on the internet that are running with hydrogen, with fuel cell. And then these are some cars, new models, cars. They develop more than 2,000, 3,000 different kinds of fuel cell car. This is, you can see in hydrogenusa.org, all this model here, and with characteristics of the cell. I take more attention for the Mirai, a fuel cell car. Yes, you can buy this car today, and they have 500 kilometers the autonomy, very speed car, and they have a fuel stack from 140 kilowatt. They have 2 hydrogen tank, but there's a pressure tank. I will show you. This is dimension of the car, and it's a normal car. Nice car, it's not normal car. And here is, you can see the fuel cell stack. They work with a battery. They have 2 systems. It's a fuel cell stack and a battery. Then the battery gives the power when the car starts to run, and the fuel cells work with the normal velocity, with the high efficient process. Here is the fuel cell stack. It's a PEM fuel cell stack with very new technology, very thin plate, very thin catalyst. And here's a boost converter to convert the tension of the cell. Here you can see the new system, but look here, promote back diffusion of the water. Then you see here the water still have the same problem. The water is a problem of the cell. In this moment I have problem with this cell here. The water blocked the gas canal. I need to just block very fast now. This is more easy. But here you have a back diffusion from the water to humidify the anode, this kind of membrane here. They reduce the size of the stack and they change all the technology of this stack here. The tank that they use 700 bars, high temperature stack. They work with carbon fiber, reinforced plastic layer here. It also is a very high-tech tank. Fuel cell electric bus. Also in the world we have a lot of fuel cell bus, more than 80. In Brazil we have 4, 5 fuel cell bus. 3 here in São Paulo, in São Bernardo do Campo, MTU, and we have one in Rio de Janeiro. Here, what's I think amazing, Ballard announced, this is for this year, announced planning to develop 500 fuel cell commercial trucks in Shanghai to export fuel cell truck to China. And what is the fuel cell bus? We have normally it's a hybrid system. You have lithium batteries on the top with the tank, hydrogen tank. And there is motors, electric motors to run the bus. In here you have pour water exhaust from the cell. Remember, you have half liter water per kilowatt hour. Hi.
Hi, Professor. My name is Ulisses. Do you have any comparison between the electrical car by photovoltaic and the electrical and the hydrogen car? Because today are marketing about the electrical car by photovoltaic. So, but I think there is some benefits if you use one or other.
Yeah, I have here on my computer, but it's not here on the presentation. I can put on the presentation that everyone have this data. The name is a Ragon curve that you can compare different kind of power and energy and different kind of fuel. You compare different kind of batteries, you compare different kind of hydrogen fuel cell. But hydrogen, you don't store energy, you convert energy. The hydrogen, the energy from the hydrogen is on the tank. The battery stores the energy on the battery. And to produce the energy, you use photovoltaic. To produce hydrogen, you can also produce from photovoltaic. But if you use photovoltaic direct on the battery, on the fuel cell, you need to transform the energy from photovoltaic, go to electrolyzer, and the electrolyzer go to the stack. And then you have some efficient problem. This is the point, the efficient problem. Normally, for electrolyzer, you need 5 kilowatt electrolyzer to produce in one stack 1 kilowatt. But if you use a high pressure tank, the autonomy that you will have, it's much more that you will have in a lithium-ion battery. The best lithium-ion battery with hydrogen will have more autonomy. If you compare efficient, forget the fuel cell. If you saw in autonomy, great. But then depend of the price that you have and what you like to do. Photovoltaic is good for both systems. One will have more autonomy, it's more complex. Fuel cell is more complex than a battery, but you have more autonomy, much more autonomy. And this curve I can put here. Good question.
Hello. So I was just also wondering, do you have, do you know how much costs more or less the kilometer on a fuel cell vehicle compared to a kilometer with an actual diesel engine? And how much do you think, like, can we reduce it? I don't know, with it becoming more common and more used and this type of stuff.
Yeah. Your question is very complex. Because first, you depend what kind of hydrogen we will use. And we are competing with a industry, very strong industry, with a large capacity to produce. On the side, we have a very small industry with the cooperation, also big players, but the market is very little. If you saw on the future, fuel cell and hydrogen could be much less, much have lower price than with gasoline because they have more efficient. But the motors, the engines will evolve more. They have much more to evolve. The ethanol motors, they need to be have a lot of things better to do for ethanol motors, to have better efficient. Then both technologies have to increase the development to have better results. If you compare price, we can produce ethanol from hydrogen from ethanol, and ethanol can run direct on the car. If you saw the complexity of the system of the fuel cell on the engines, fuel cell is much less complex than the engine motors. But the engine motors have more than 100 years and have a lot of company working there. Then if you use the same fuel for engine and for fuel cell, the same fuel, if on the future, with the fuel cell we have more efficient, because we are not limited of the Carnot cycle, then sure that could be a better price with fuel cell that from engine. So it's not good to read, but here we can see some data of the fuel cell stack from Toyota. And then here we can saw the net power, 6 kilowatt, 85 kilowatt, 100 kilowatt. And here the fuel cell size, the weight, the kind of system to cooling system, safety compliance, and the consumption here. Oh, and CV. Okay. So here for material handling. We will see that we have a lot of application. We have more than 7,000 fuel cell powering material handling in application running today. Also in big companies, Walmart, Cisco, Protector, Gamble, BMW, Coca-Cola, all big companies are working with material handling. Here is a American company, Plug Power. Here's the charger dispenser, fuel cell dispenser. Here's the forklift. In about 1 minute, you fill the tank with this. 1 minute. With lithium battery is about 1/2 hour. With lead battery is about 10 hours, 12 hours. Then we reduce 12 hours to 1 minute. Very fast. This is new for me too. Look, drone. You can buy drone with fuel cell. Drone. Why they will use drone with fuel cell? I have only one answer. Autonomy. Only. Then we know that for drone, they have more autonomy. And what the cells they use? PEM fuel cell. They have more efficient, more power density. This is the reason that the PEM fuel cell is so good. It's on the market. You can buy now. I try to see the price this afternoon. And on the internet, look here. A lot of drone. I never saw this. I like drone. But I never saw a lot of drone on the internet. And here a charger, pressure tank, in different kind of, look the tank here, hydrogen tank, here. They can use also hydrate metal to increase also more the autonomy of the fuel cell. Not to use hydrogen tank, use metal hydrate. It's amazing. And then here is international partnership for hydrogen economy and fuel cell economy. All the country here, they decide how they develop the fuel cell, what they need to develop, what's the problem that they need to resolve, to work together to find solution to increase, to go faster the hydrogen economy. Brazil is here. Today, this month, last month, Brazil was represented. The Congress was in Kobe, in Japan, and Paulo Emílio from Federal University of Rio de Janeiro was the representative of Brazil. Normally, government participate of this meeting. There is another big group that start this year, beginning end of the last year, but start with this year, with a lot of big company. Look, AGA, Bock, Honda, Nel, a lot of big company working on Toyota, working to develop fuel cell, to increase the velocity of the development of fuel cell, or Nissan, Hyundai. But they have another group. Then there is a European Association for Hydrogen. This European Association have 20 local associations of fuel cell. We have 20 fuel cell associations only in Europe. In Canada, they have 2 associations. Brazil, we have 1 association of hydrogen. We found this year. And here we can see the infrastructure, the refueling infrastructure for hydrogen. This is from Europe, from TISA, Hydrogen Mobility Europe. This point here, where you can refuel your car. They like to have new hydrogen fueling station, 20 in German, 10 in French, 10 in Scandinavia, United Kingdom, 6, Netherlands, Holland, 1, and 500 fuel cell vehicle, electric vehicle, 900 fuel cell vans. This is impressive. A lot of cars that will start. This is gone very new. This is what's from yesterday too. Look, all this here, you see here, net inform, is hydrogen tank for cars. United States, Japan, South Korea, China, USA, California. And look, if you go with your car, you can find the address of every refueling station. You can have now a car. Pay attention to your next model fuel cell car. So, here what we produce is this very new product. It's a 5 kilowatt for INT, National Institute of Technology in Rio de Janeiro. Then we develop a stack with 3 models stack, 3 different sizes that we use hydrogen. We like to compare different model size in parallel and see what happens using hydrogen from hydrogen obtained from natural reforming. We control every stack. Everything what happened is we had one big problem. Now more, we see the senoid of the current with charge, without charge. They need to be the same. You can have this problem here. We have a line here. It's perfect senoid. This is another project from CEPEL. It's an old model that we put in parallel with a reformer. The same that the picture I show you. And here is also a very new project. This company here from AVL. Here, he present on WEC Congress. There is a REX, extended energy for the cars, for the batteries, and they put here ethanol stack with solid oxide fuel cell. This happened this year. And here's the stack, also a new generation stack. They put a 5 kilowatt stack, and then they increase the autonomy in 600 kilometers range using the REX. It's amazing. On efficient, look here. We have another company, a Hydrogenics. It's a fuel cell company, electrolyzer company. They have here also a stationary application for data center. They have 60 cells. Each cell has the area of 500 cubic centimeters. They use a bipolar plate molded. When you use molded, you will have more conductivity. And that stack produce about 12 kilowatt. If they produce 12 kilowatt, here, they will need a bigger size stack, because they will lose energy on the controller, on DC-DC converter, on the UPS and waste heat. And also they lost heat and on the exhaust gas. And then the total remove via cooling is 10.5 kilowatt and 10 on the electrical power. Then you can see here that the efficient is lower. Here is the biggest world large operation of molten carbonate plant on the world. They have about 60 megawatt in South Korea. The plant is fuel cell energy, molten carbonate fuel cell. And so I stop here. We start here to playing with the fuel cell. If everyone like to come here and to see how we run with a fuel cell. Please. If everyone have a question or before the course, please send me an email. In our presentation here, have my email. Please, come here. Ó, aqui temos uma célula combustível pequena. Ela tem uma área ativa de 20. Sorry. Here we have a small fuel cell. We have an active area of 25 cubic centimeter, 5 to 5. In one side is a cathode, another side is anode. Here we can put the hydrogen in, and here, other side out. Here come the oxygen in, here out. If we put this side in, what will happen? The water will produce here inside. If you have any condensation here, they will block the entry of the high oxygen, and the potential will jump. Then here we have a voltmeter, and here a current, a meter. Here we have 1 cubic meter hydrogen, and here we have oxygen. Here have the photometer. It's closed. We have pressure here and pressure here. Okay, then we start. First, the current collector here. Here the meter is in series on the fuel cell, and the voltage direct on the both contact here. We see here, if we open, so, okay, and we need the gas. And oxygen. You saw here, 5 volt, 0.5 volt, 0.2 ampere. Now I will start. There is a residue hydrogen here inside. I will increase here. We increase the tension here. I will put a little here. The current will increase. But my motors have a problem. Go. We start. What will happen here? We don't have any modification. This is a problem for the cell. But, oh, thank you. The run, see here the tension. When he start, the tension decrease. This is the polarization. And the current increase. Yeah, the maximum is, we have here, if we work with 2 ampere per cubic centimeter, we could run with 25 ampere here on this kind of fuel cell, or more. But my motor is this problem. Go. Okay. I think my motor is this problem. This is a motor when I was a child. So, what you can see here, potential, if you reduce, I will increase, how the tension start to reduce. Maybe I have some flooded water here. But we have here a problem that we have a low voltage. This morning was nice. Sorry?
That I was asking what would happen if the motor becomes a generator for some reason. If the motor becomes a generator at some point, what will happen with the cell?
Virar, what happened? When ventilador? This when it starts, we will consume more energy, and then when they consume more energy, the power, the tension will decrease, and here's the tension, the current will increase. How much more power they put here, decrease here, and increase here.
Electric motor, and at some point the load, the mechanic load increases. It's not a load anymore, it's an input of load, so it becomes a generator.
Okay, so with here, I will put in series, no problem. If we put all the cell in series, we can put another component all in series, but where they have the minimum current will be the current for all the system. If I put here another fuel cell, the current is very low. The current for all the system will be the lowest current.
Okay, but what if the power flow is in the other direction? It's entering the fuel cell? What will happen?
It could be electrolyzer,
Okay.
but you then have here electrolyte. You have water here.
It would damage or not?
Yes, could be. Could be.
That was
You need to take care. I will start again. I hope it's better now. No. Maybe produce water here. And wait, I have a. Can you stop the film now? I will do things like